Alright, welcome back. We're gonna go and try this example. We're gonna find the limit using the table, the limit of this function. And the way we're gonna do this, we're gonna introduce this process is by setting up the table, and then we're gonna talk about how this table is gonna help us make the proper conclusions for the following three limits, right? So let's just jump into the table. Let's fill up the table, and there is a way we can use the graphing calculator to help us generate these numbers. So let's bring out the calculator. All right, so bear with me. Being the first time here, showing you guys how to do it with a table with the calculator, I'm gonna go step by step, make sure that everyone can follow. So what we're gonna do, what I would prefer is that we make a table for this, right? So what we're gonna do here is we're gonna graph this. Sorry, we're gonna go second and then table, and this is going to generate the graph, right? So first we're gonna have to go and change. We're gonna type in the equation on the function. So right here where it says y equals, we're gonna type in the equation. So we have to be careful here. We have to put parentheses for the top part, for the numerator. So we're gonna put parentheses x squared minus 9, and then all over divided by, again, parentheses, x minus 3. Okay, so if you notice, I have to put the parentheses because I have to group them together, because otherwise the calculator wouldn't know that we are grouping the numerator and the denominator, right? So let's try now, figure out set up in the table. So second, again, and then table, also graph table, and this is already generating some answers, if you notice, and that is because x is already it's already giving us all these values for x, right? The computer already generated those numbers for x, but we want to input those numbers, right? So what we want to do is we're going to change the settings for the table. Right where it says window, on the top menu, it says window. We're gonna go second, and we're gonna go table set, right? So if you notice, if we move down here where it says the independent is automatically generated, we want to instead of have be automatically done by the calculator, we want to ask the calculator what numbers to plug in. So we're gonna press enter, and now it's highlighted with ask. The dependent should be auto, and now we can go back to the table. Second, and then the graph, so we can get the table. Now you notice the table is not filled anymore, and that's because we're gonna fill it up. So let's try 4, and by plugging 4, you already got 7. Plug in 3.1. Oh, sorry. Let me clear that up. Let me try this again. Delete, clear. Okay. Let me try that again. So second table, and let me move up, and there is a way to clear this, right? Second graph. All right, let's try this again. So 4, and then we got enter. That way we allow us to move down. So 3.1, enter. 3.01, enter, and then 2.99, enter, and then 2.9, enter, and 2.5, enter. All right, so we're gonna type in those numbers in our table. So let's see, 7, 6.1, 6.01, 5.99, and 5.9, and 5.5. Right, so we're done with the calculator, so I'm just gonna remove it. So all right, so what we have here is, if you notice, if we write ourselves a note, what we're saying is, as x, it seems like x is approaching the value of 3, right? If you notice, x is approaching, if we see the number line of x, if you have 4, you have 3 here, you have 2 there, you have 4 there. If you notice, the top part is approaching is getting from 4 to 3.1 and then 3.01. So the numbers of x are getting close to 3, right? So x is approaching 3 from the right side, and then on the bottom part we see that x is approaching 3 from the left side, right? By showing that what do we have, 2.99, 2.5 right here, right there, and then 2.9, and then 2.9, right? So we're getting closer and closer and closer. So what we see here is that x is getting up close to 3, and then x is approaching some number, right? That's what we're trying to figure out. So knowing this information, we can think about this as being x approaches 3 from the right side, and then the bottom part is x approaches 3 from the left side. We talked about this on the last video, so I refer to that. All right, so let's try and answer this question. So based on the table values above, what conclusion from below limits can we make? Can we argue by looking at this part right here, that as x approaches 3 from the left side, right, the values of the function is approaching what value? Is it approaching 6? It seems like it does, right? Because we are getting 5.5, 5.9, 5.99. So it seems like yes. And we can argue that it would have been more obvious if we would have even got closer to 3. So let's try this again for another problem. For the second part, says, well, what about if you're coming from the right side? If x is approaching 3 from the right side, let me make this. So if we're getting x is approaching 3 from the right side, what is the value of f of x approaching to? And it seems like, right, it seems like it is going from 7, 6.1, 6.01. So it seems like it is also approaching 6. Yes, right? So the conclusion here now is, well, what about is the limit of the function as x approaches 3 is it 6? And the answer is yes. How do we know that? Because in order for this to exist and to be 6, these two need to be 6 as well, right? They have to come from the left side and right side. They have to be both the same number in order for this to exist. So that means that in our conclusion that we had over here, right, this is going to exist if those two exist. All right, so that's it for this example. I hope you guys find this helpful. We'll try another problem in the next video.